Each year, billions of tons of soil are lost through soil erosion. Erosion reduces soil productivity and deteriorates the quality of our soil and water. The resulting sediment causes stream pollution and reduces the capacity of our reservoirs. Erosion removes the topsoil first, eventually exposing the less productive subsoil beneath. In the most severe cases, eroded land may no longer be productive and must be abandoned. Soil erosion is a gradual process that is caused by two forces of nature, wind and water. Water erosion begins with the force of each individual raindrop. Raindrops may seem insignificant, but they strike the ground with amazing force. Rain can pound the ground at speeds of up to 30 miles per hour. An intense storm on bare soil can loosen and detach up to 100 tons of soil per acre. When raindrops strike bare soil, they dislodge soil particles and can splash them as far as 3 to 5 feet away. This process is greatly exaggerated on a downhill slope. As soil particles are dislodged, they can fill in or plug surface pores in the soil. This prevents water from infiltrating into the ground. Instead of soaking into the ground, the water carries soil particles across the surface, creating runoff and erosion. Water erosion can be classified in 5 different types: sheet, rill, ephemeral, gully, and stream bank. Sheet erosion is a subtle type of erosion that can be very damaging over time. It involves the loss of thin, uniform layers of topsoil over the entire field. Soil loss can go almost unnoticed until many years have passed and the subsoil is exposed. By the time you notice the loss, the damage is already done. Rill erosion is easily identified as a series of little channels or rills that cut into bare soil. These channels occur on slopes and are small enough that they can be removed by normal tillage. Rill erosion cannot be predicted and will occur randomly anywhere across a hill slope. The third type of water erosion is ephemeral. This differs from rill erosion in that it usually will form in the same location year after year. It develops in natural depressions where there is a concentrated flow of water. Like rill erosion, it can usually be erased by normal tillage methods. Gully erosion forms channels that are too large to be erased by ordinary tillage. When left unchecked, the top of a gully, called the head, will continue to cut upslope. Head cut development and gully erosion seriously threaten soil resources and the sustainability of farmlands. Deep, wide gullies severely limit the use of land, making it impossible for farm machinery to cross. The final type of water erosion is stream bank erosion. This process is caused by the continuous flow of water through a channel, which cuts away the stream bank. It is generally a slow process, but can speed up dramatically during floods or heavy rainstorms. Stream bank erosion may change the course of a river or creek and causes severe erosion in that specific area. Wind erosion occurs as the wind picks up and moves small particles of soil. As wind speeds increase, the amount of soil picked up on a bare field may easily double or even triple. For instance, if a 20-mile-per-hour wind increases to 30 miles per hour, the rate of erosion triples. There are 3 distinct types of wind erosion: creep, saltation, and suspension. Laboratory studies have shown that more than half of all soil eroded by wind is moved by saltation, with the remainder about equally divided between suspension and surface creep. Wind erosion typically begins at ground level, as the wind causes soil particles to roll or creep over the ground. Particles roll or slide in almost continuous contact with the soil surface. Creep erosion is an extremely slow process and difficult to see without a lot of time and measurements. Wind moving soil particles in a hopping or bouncing fashion is called saltation. With each bounce, the grains typically reach heights of less than 2 inches above the surface and move horizontally about 2 to 4 inches. The impact of the particles falling back to earth dislodges additional soil that is sent in the downwind direction. Wind erosion is most visible during the suspension stage, when soil is actually moving through the air. This is seen most dramatically during a dust storm. Soil particles suspended in the air can move hundreds or even thousands of miles before they are deposited. Water and wind erosion are naturally occurring processes that have been accelerated by many human activities, such as farming, construction, and other soil disturbance activities. Everyone should be aware of the potential damage that wind and water can inflict on their land and explore necessary measures to reduce their harmful effects.